3, we are given a particular graph of g of x, and then we're given the graph of f of x, and we want to answer these questions. Well, let's right now see if we can actually add to this graph. So let's type in this function. Go second plus 712. Go up to y equals. And let's type in, I'm going to put it in parentheses, the square root of 2x plus 5. I have one beginning parentheses. I'm going to close that off. And behind the radical, I'm going to subtract 1. So I can see that this radical has been shifted. And the starting point of the radical. And we also can see, so if I zoom in here, just so we have a little bit better view of things, I can see that I've shifted this down, I've translated down, and I've moved this to the left. Okay, so this is what it's looking like right now. Okay, let's get the numbers on this. Let's see, where is this starting point exactly. So let's hit trace. Now we can be able to determine that by just looking at this, by the way. Remember how if this is like a plus 6, we actually go to the left? Okay, I want you to look at this and see how can we figure that out. Let's hit trace and see where this number is, approximately. Oops. You have to wait till this jumps on. So it's right about here, right? Yes or no? Okay. How can we figure out exactly what that is? What do you think that is? Try this once. Go second, trace the value, and type in negative 5 halves and press enter. Why did I choose negative 5 halves? And I chose that because I took this and I set it equal to 0. So I subtracted 5 and I divided by 2. So that's the starting point of this x value. So this starting point of this, I call it the starting point, of this particular radical goes to the left negative 2.5, and then it's shifted down 1. So let's do that over here. Let's see if we can extend this. Here's negative 1, bless you. Here's negative 2. Make it go over to negative 2.5 and then go down 1. So there's negative 2.5, bless you, down 1. Hit second table so we can graph this. And we can see that negative 1, we can approximate. Negative 1 goes to 0.7. Negative 1 goes to 0.7. And 0 is 1.2. 1 is 1.6. And we can kind of go out here a little further. 2 is 2. 3 is 2.3. You can continue to look here. I inputted the function they gave me for f of x, and I graphed it on the exact same coordinate plane. Now I'm going to answer the questions. Which statement about the two functions is true? Which statement about the two functions is true? All values of x of this graph are always greater than this graph. So that means, hold on one second, if I specify a certain x value, is it true that the x's or the y values of this function will always be greater than the y values of this function? So let's do 5. Find where x equals 5. Let's go x equals 5. So at x equals 5, what is the value for f of x? Approximate it. This is f of x. What is the value? Could we say 2.9 approximately? So the value here is 2.9. Now find g of x. At 5, what is the value approximately for g of x? 6.5. So for all values of x, all I need to find is one that's not true. Is it true that 2.9 is greater than 6.5? Not true. As x goes to the far left, so as I go to the far left, is it true that g of x is always greater than f of x? So as I started, let's even go with 0. I can see that for g of x, if I continue at this rate, it looks like if I do a quick approximation, just approximation, 1, 2, 3, 4, 5. Maybe about negative 5. So when x equals 0, this is going as go to the far left. When x equals 0, I can see g of x is at negative 5, and f of x is at 1.2. Is negative 5 greater than 1.2? No. That's as I go to start going to the far left. As I go, bless you, as I go to the very far right, is it true that f of x, as I go to the far right, will be greater than g of x? Well, do you agree that this continues to go upward? So will these y values continue to go up? Do you agree g of x continues to go down? So is it true that the f of x values will be greater than g of x as I go to the far right? That is the true statement.